M1L25 is adding and subtracting rational expressions. In other words, we're going to do a section that is going to be about adding and subtracting fractions. So I'm going to go through a series of problems that kind of showcase this and demonstrate this, some simpler, some a little bit more complex than others. But remember, the ultimate goal is the same. We want to have common denominators, and once we have common denominators, then we can add the numerators. So if we look at exercise number 1, it says calculate the following sum, 3/10 plus 6/10. Since this denominator here and this denominator here is the same, we just add the numerators, 3 plus 6, and you get 9. The denominator remains unchanged. So that's what we strive for, no matter how simple or complex the problem is going to look. That's our goal. So if we looked at number 2, for example, it says 3 over 20 minus 4 over 15. So to do that, we have to get common denominators. That common denominator is going to end up being a 60. So we're going to multiply this fraction by 3, and we're going to take the other fraction and multiply it by 4. So multiply by 4 and multiply by 4. So when I do that, I'm going to end up with a fraction that says 9 over 60 and then minus 16 over 60. Again, note that I now have common denominators. So once I do that, I do 9 minus 16. I'm going to get negative 7. And then that denominator remains the same. So in number 3, nothing changes. We still have a denominator of 4 and a denominator of 5, so we need to get a common denominator. To do that, we're going to multiply this one by 5. And we're going to multiply this one by 4. And so, again, you just got to be careful with the writing a little bit. When we do 5 times pi, we get 5 pi over 20, and we do the square roots of 2 times 4. Remember, you're going to get 4 square roots of 2, not square roots of 8. So you just want to be mindful about that. And then 5 times 4 is 20. And so when we add this up, this is one case where these are not like terms. So really all we do is we write 5 pi plus 4 square roots of 2. And we're going to write that over 20. Since there's nothing common between a 5, a 4, and a 20 that can be simplified, nothing divides into all three, we leave it alone. So then that takes us to number 4, where we have a bunch of variables. So here we have an m, a 2m, and an m. So to get a common denominator, I need to multiply this one by 2, so we have a 2m. We already have a 2m here, and I need to multiply a 2 here, so I get 2m's across the bottom. So when I do that, my new problem looks like this. 2a over 2m plus b over 2m, that middle fraction remained unchanged, and then 2c over 2m. So again, logistic-wise, none of these are like terms in the numerators. So we just end up writing 2a plus b minus 2c, and all that's over the common denominator, which is 2m. So this is what we're going to be showcasing today, just varying levels of difficulties and so forth. So if we look at example number 1, part A, they want us to add these two together. So again, we notice at the bottom we do not have common denominators. So we multiply this one by 5. Since this is an a plus b, I need to put that in parentheses and multiply by 5. I need to multiply this one by 4, and since this is an expression, I need to multiply it by 4 as well. So what are my new fractions? My new fractions are 5a plus 5b. Let's write that a little bit nicer. Over, that b did not curve out real good. There we go. Over 20. And then we're going to add that to 4 times 2a is 8a. So we'll write 8a minus 4b over 20. Now that the denominators are the same, we can combine like terms. So 5a plus 8a is 13a. So we get 13a. And then 5 plus negative 4 is positive 1b. So we put plus b over 20. So same thing happens down here. We have a 3x and a 5x squared. So to get a common denominator, I need an x squared on this one. So I'm going to multiply this one by x. And I need these numbers to be the same. So I'm going to multiply this by 5x. So I'm going to multiply this fraction here by 5x on top and bottom. And we're going to multiply this fraction by 3. Right now, if you don't understand why, just watch and see what's going to happen here. 5x times 4 is 20x. Remember, our goal is common denominators. So 5x times 3x is 15x squared. 3 times 3 is 9. And 3 times 5x squared is also 15x squared. Remember, that's our goal. Our goal is common denominators. So now I could subtract, but these are not like terms. So my answer ends up being 20x minus 9 over 15x squared. Now 4, enough. Yeah, that's 4. That's what they call that? No, that should have been letter C. These are written a little bit messed up. That should have been a B. That should have been a C based on my book, right? So this was part B, and now we're on part C. And so now when we look at these, we have more complicated denominators, which means I need to factor them out to see what their factors are. So the GCF of this one is 2x, and that leaves me on the inside with an x plus 1. That's the factors of the first one. This one here, when I factor it out, I'm going to get an x and an x, and then we're going to put a minus 4 and a plus 1. So in this case, when I'm trying to figure out what's missing in each denominator, I look to the factors. So for example, both denominators have an x plus 1, but this one is missing a 2x. So I need a 2x on this side over here. So that means I'm multiplying top and bottom by 2x. And this side is missing an x minus 4. So I'm going to multiply this one by x minus 4. Now if you notice, both denominators both have a 2x, they both have an x minus 4, and they both have an x plus 1. So now that I've accomplished that, I can take and I can multiply these two together. So I get 3x minus 12, and then plus a 10x. Right, that's all over my common denominator of x minus 4, x plus 1, and 2x. And then 3x plus 10x is 13x. So my final answer is 13x minus 12. And that's over my common denominator, which I don't have to multiply back together. Just leave it as the factors that they are, and then call that a day. All right, so if we look at exercise 5, again, same idea. I have a denominator of an x minus 2. I need to factor this one. The GCF here is a 4. And so that gives me with an x minus a 2. So what I observe is they both have x minus 2's, but this fraction on the left it's missing a 4. So we're going to multiply top and bottom by 4. So that means my new fractions look like this. 20 over, with a 4x minus 2, plus a 3x with a 4x minus 2. Now my denominators are the same. I can add my numerators, and that's going to give me 20 plus 3x, and then I leave my denominator exactly the same. So when we look at the fractions at the bottom, we have an m minus 3 and a 3 minus m. We would really like to have m minus 3's in both. So to do that, what we're going to do is multiply each one by -1. So we need a -1 on here and a -1 on here. So what that does now is it gives us this problem here. 7m over m minus 3. We'll keep our plus sign for now. -1 times 5m is -5m. And then -1 times 3 is -3, and -1 times -m is m. In other words, mathematically, that reverses these two values, so it says m minus 3. And so 7m plus -5m is 2m, and we leave that over m minus 3. Number 7, right, we have b squared over this piece, which we need to factor, minus b over b minus c. So we're going to factor here and see what's in this one. We put a b here and a b here, and it looks like to get this we need a minus c and a minus c. So now look at this one. We have two b minus c's over here. We've only got one over here, right? This single b minus c. So to make common denominators, I need to multiply by another b minus c. And so what I do to the denominator, I have to do to the numerator as such. And so now what I end up with, a problem that looks like this. B squared over, and for the sake of space, I'm going to write b minus c squared. And I'm going to put a minus sign. B times b is b squared, and b times c is negative bc, and that's over b minus c squared again. And so when we subtract b squared minus b squared, that cancels, and then negative a minus b makes us a positive b. So our final answer is positive bc over b minus c squared. Let's see if we can clean this one up so we can see there's the fraction bars. So same idea, right? This is a difference of squares, so that factors into x minus 1, x plus 1, and if we factor this one out, this is an x and an x. I'm going to say what, a plus 2 and a minus 1. So we're to look and see what's missing in each one. So this is an x minus 1 and x plus 1. Over here, we have an x plus 2 that's not present over here. So we have to put an x plus 2, and we have to multiply the numerator by x plus 2. So let's look at the right-hand side. We have an x plus 2 and an x minus 1, but I need an x plus 1. So we're going to multiply that to top and bottom. So x times x is x squared. So we end up with x squared plus 2x. That's over my denominator of x plus 2, x minus 1, and x plus 1. We have a minus sign. This will be 2x squared plus 2x. And that, of course, is over my same denominator, x plus 2, x minus 1, and x plus 1. So now when we subtract, now we have a common denominator is 1x squared. So, right, 1x squared minus 2x squared is negative x squared. 2x minus 2x is 0. So this is the only thing that's in my numerator. Let's clean that up. Right, negative x with a 2. And then we have an x plus 2, x minus 1, and then an x plus 1 as my denominator. Okay, so that covers most of the section. What we have left to look at is a complex fraction that has a lot going on in it. And so what we're going to do is we're just going to kind of break this down a little bit and see what happens. Right? So some ideas to see is we've got a division bar here. And we know that we don't divide by fractions. So if we do see a division by fraction, we tend to take the reciprocal of the fractions and multiply. So we will do that. So we're going to end up writing, when we write this down for initial solving, we're going to start to factor some things out. So this one right here, we're going to factor out immediately to a b and a b. This is going to be a negative 1 that may not actually be factorable, is it? So we're going to leave that one alone for now until we see what we're going to do with that. So we're going to write b squared plus b minus 1, and we're going to leave this over 2b minus 1 with a minus 1 behind it. And where this says division, we're going to change that to a multiplication, and we're going to take the reciprocal of the other fraction when it's time to. But what we may do is, just for now, for visualizations, just rewrite it as such with a division sign. We'll put this in parentheses so we know that this is together, and then we're going to be dividing it as such. 4 minus 8 over b plus 1. And then we'll take it from that perspective. So let's say we deal with the first fraction alone, okay? So we'll do this. We'll take care of this one first. We want to subtract these. I do not have common denominators. So to do that, right, and I'll write all of this in blue. This all refers to here. We've got b squared plus b minus 1 over 2b minus 1 minus 1 over 1. So that means I need to multiply this one by 2b minus 1 and 2b minus 1. That's going to give me common denominators. So by doing that, right, that essentially turns this fraction right here into 2b minus 1 over 2b minus 1. Now I have common denominators, so b squared, b minus 2b is negative b, and negative 1 minus negative 1 is going to be 0. So that leaves me over 2b minus 1. So this is that first fractional result. We'll put that in parentheses so it stays together. Now let's address the other one. Let's say we do this one in green. So now in that one we have 4 over 1 minus 8 over b plus 1. So that means I need to multiply this side by b plus 1 on top and bottom. So that's going to give me a 4b plus 4 over b plus 1, and we're going to minus 8 over b plus 1. So now I subtract. I'm going to get 4b, 4 minus 8 is negative 4, and that's over b plus 1. So this is my second fraction. So now that we have that listed, what we're going to do is we are going to divide the two results. So right now we are at the point where we are saying we've got b squared minus b over 2b minus 1. We want to divide that by 4b minus 4. But remember, that's equivalent to saying this, b squared minus b over 2b minus 1. And we're going to multiply that by the reciprocal, b plus 1 over 4b minus 4. We want to copy this. Let's see. Edit. I'm going to copy. We're going to go to a new slide. And we're going to paste that. And let's move it up here so we can continue. So now that we have this, we're going to factor what we need to factor. So this here, there's a greatest common factor of a b. So it gives us a b minus 1. The denominator remains a 2b minus 1. The numerator is a b plus 1. And we factor out a 4. You get another b minus 1. And so therefore this one and this one will cancel. And so then my final answer is b times b plus 1 over 2b minus 1 times 4. Typically we write this the other way around, the 4 in the front. So it would be 4 times 2b minus 1. You can leave the answer like this, or if you want to take it a step further, you can write it as b squared plus b and then 8b minus 4 if you'd like. So that's example number 2 and concludes this lesson. So then that takes us to the problem set where you're going to work and practice some more problems similar to these.